Hi, my name is Kemal El Moujahid, and I'm a product director for machine learning at Google. While the number of edge devices continues to increase, they're also becoming more powerful, making it possible to build ML-powered apps that we would have never imagined before. We want to put this power in your hands, no matter where you are in your developer journey. Whether you're an iOS or Android developer, we want to give you the tools to be successful. The first place to start with is MLKit. For common ML use cases, MLKit offers easy-to-use production-ready turnkey APIs. From barcode scanning to language identification, MLKit offers 13 unique cross-platform APIs which run well on both low-end and high-end devices and are completely free to use. We're continually adding new APIs and updating existing ones, so you can be assured that you will always have the latest and greatest that Google has to offer. For developers with more custom needs, we provide TensorFlow Lite, Google's open-source ML framework for on-device inference. TF Lite is used widely for powering on-device ML in Google apps, as well as popular external apps on more than 4 billion devices. In addition to model inference, we recently launched on-device training in TF Lite. You can now train your TF Lite models on mobile and other edge devices, just as you would train your TensorFlow models on server. On TF Lite, we continue to work on making performance better. XNNPack, a library for faster floating point ops, is now turned on by default in TF Lite, allowing your models to run on an average 2.3x faster on the CPU. Once you've trained and optimized your model, the next step is to distribute it as widely as possible. To help with that, we're adding the TF Lite runtime to Google Play services, so you don't have to bundle it with your app. This means no additional APK size increase. Plus, you get automatic future updates. Many apps have already deployed this feature in production. If you're interested in trying it out, you can sign up for an early access program. Attend the on-device ML talk later to learn more. And finally, you can now run the same models in the browser thanks to TensorFlow.js. This means they'll work on feature phones as well as desktop Electron apps or anywhere else JavaScript can run. This lets you use the same model across billions of mobile devices running Android, iOS, Linux, and other edge devices. Let's take a look at an example of an app powered by TF Lite. Lookout on Android helps people get details about objects and text around them. This is especially important to help people who are blind or low vision complete daily tasks faster and more easily. Lookout recently introduced a new mode, Food Label. With Food Label, you can quickly identify packaged foods by pointing your phone's camera at the label. Lookout will guide you to position the food product so that it can be properly identified through its packaging or barcode, helping a user distinguish between, say, a can of corn and a can of green beans, which would both feel identical to the touch. Lookout's different modes, including its object classifier and OCR models, are powered by TF Lite. We also know that you need to run your models across vastly different hardware, from the latest and greatest phone all the way to tiny microcontrollers. There are now hundreds of billions of microcontrollers and embedded systems. And with TF Lite for microcontroller, you can run ML models on microcontrollers with only a few kilobytes of memory. So for now, we've talked about a simple workflow, from building to deploying a single model. But when we move to production ML, we discover that workflows are typically more complicated, and there is a lot more that is needed to be successful. At Google, we've measured the ML model code to be something like 5% of the total code necessary to train and deploy a model in production. All the other tools and infrastructure that you see here are critical. Now, how do you manage such a large operation? With machine learning operations, or MLOps. MLOps is an ML engineering culture and practice that aims at unifying ML system development, dev, and ML system operations, ops. Practicing ML ops means that you advocate for automation and monitoring at all steps of an ML system, including integration, testing, releasing, deployment, and infrastructure management. Like DevOps, we also need processes and infrastructure for continuous integration and continuous deployment. For that, we use TFX, an open source solution for the entire problem of machine learning operations, from storing and pre-processing data to model validation. Let's take a look at an example. OpenX operates the world's largest independent advertising exchange. At a basic level, the exchange is a marketplace connecting tens of thousands of top brands to consumers across the most visited websites and mobile apps. They used a TensorFlow serving deployment running on Google Kubernetes engine, serving 2.5 million prediction requests per second, under 15 milliseconds each. They've been able to make dozens of improvements to their model, everything from changing the architecture of the original model to changing the way certain features are processed without support from any other engineering team. Now, as always with Google tools, we're working hard to make AI fair and responsible. To that end, we've integrated the fairness indicators and the model card toolkit directly into TFX. I'm also excited to announce V0.4 of our language interpretability tool, or LIT. LIT is an open source platform for visualization and understanding of NLP models. This new release includes new interpretability techniques like TCAV, Targeted Concept Activation Vector. TCAV is an interpretability method for ML models that shows the importance of high-level concepts, for example, color, gender, race, for a prediction class. Now say that you're looking for a managed system for MLOps. Vertex AI is a new managed machine learning platform available through Google Cloud to help you with TFX at scale. Vertex AI has tools that span the entire developer workflow, from data labeling, notebooks, and models within a single console experience, to prediction tools and continuous monitoring. All these offerings may be familiar to you, but what really distinguishes Vertex AI is the introduction of new MLOps features. For example, Vertex AI gives you the flexibility to use AutoML, which automates model training so you can build sophisticated models faster using tabular text, image, or video data, as well as custom model training and explainable AI. And we've seen exciting user adoption. Since we announced general availability in May 2021, the volume of training has increased by over 70%. The volume of predictions has doubled. The number of GPU hours for prediction has doubled. And the total volume of API requests has tripled. Let's take a look at an example. Waze is the world's largest community-based traffic and navigation app. As part of its offering, it lets advertisers put their businesses on the Waze map. Waze approached improving ad delivery as a learning to rank ML problem. They ranked candidate ads to maximize the likelihood of ads to be displayed on the mobile client. They use Vertex AI suite to train and deploy a TF model and easily integrate with the rest of their data stack. Waze has seen great results, up to 19% lift in pins displayed per session in large markets. Vertex AI delivered low latency predictions within their performance parameters and helped smooth scaling of resources as ad traffic changed through the day thanks to CPU-based autoscaling. Data scientists at Waze noted that using TFX and Vertex AI for things like data validation, transform deployed to data flow, monitoring, etc., felt like magic. All these ML frameworks and tools originally came out of research, and we're making them accessible and easy to use for you. Because ML is such a fast-moving field, it's very important for us to keep helping researchers push the state of the art and keep flowing their innovation into our ecosystem.